All right, welcome you guys. So this is a lot like 2-2 in that you just have to understand what the notation means. And if you can get that, you'll be successful because it's not at all obvious. The notation, again, it looks like multiplication's happening. So you really need to make sure that you understand what's going on here, okay? So this section is going to be dedicated to the composition of functions, okay? And what that means when you see this open circle right here, it doesn't mean multiply. So you've got to make sure, first of all, that you see the difference between this, which we've seen in the past, and now this new thing with an open circle. Okay, so they look really similar, but they are not the same. So this one means that you are multiplying the two functions, and the one on the right means that you're going to plug g into f. So the way that it works is just what I said, whichever the function on the right is, that gets plugged into the one on the left, right? So in this case, g would get substituted into f. And you can see right here, this is another way to write that. It shows g inside of f, right? If we just took good old f of x, but we left the x part blank, and we put g of x in there, that's our way of saying g is inside of x. And they can switch these two. It's not always g inside of x, okay? If for some reason they wrote this the other way around, which they quite often will, you'll see, oops, g compose f of x. Well, in this case, f, since it's on the right, would get substituted into g. So you want to think of, here's my g of x, and what I'm going to substitute in for the x is f of x, another function, okay? All right, so the way that we read these, because you've got to be able to speak the language, you got to feel comfortable with it, okay? Okay, this one over here would be f composed, or f of g of x, f of g of x is one way for you to say that, f of g of x, okay? Or f composed g. Of x. F of g of x, I think, might be the more common of the two, you guys. All right, let me make this a little bit wider so I can just go straight across for this next one then. So this one over here on the far right, oops, there we go. This one would be g of f of x, okay? So g of f of x. All right, so that's how we read these composition of functions. Okay, so it's basically substituting a function in for another function. So let's see what that looks like. It's kind of a weird concept that you're substituting an x in for an x. It felt weird to me the first time I did it. All right, so g is going to get substituted into f. And I will show you an alternative way to write this just so you get used to both. So this is f of x with g inside of it. So we are going to take we're going to take 5x plus 4, and we're going to substitute it in for the x's in f of x, okay? So you're going to substitute the one function into the other function's x's. So we've got 5x plus 4, and it's being squared, minus 3 times 5x plus 4. So basically anywhere where you saw an x, you're now going to be writing 5x plus 4 on this function. And it's up to you to do the math. The hardest part's that first step. Now you just got to like not make little tiny bonehead errors, which we all do. I'm sure some of my videos are wrong, you guys, because I've probably made some silly mistake. Okay. And then we'll just FOIL out this this binomial times this binomial. So we get 25x squared plus 20x plus 20x plus 16. All right, and then minus 15x. And I'm just going to combine these while we're at it. Negative 12 plus 1, so negative 11. All right, in descending order from highest to lowest. So we're going to take our 25x squared. We're going to write that first. Then we're going to combine our x's. So 20 plus 20 is 40. And 40 take away 15 is 25x. And then we're going to go ahead and take our constants. So we got a 16 minus 11. That's going to be 5. And this is it. You don't want to like factor it, solve it. Remember we said if there's no equal 0 over here, don't start solving or putting, I see students put an equal 0 there. Okay, this is what F composed G of X is. All right. Okay, so this time we've changed who's getting plugged into who. This time we're going to be taking F and we're going to substitute it into G. So in other words, for G of X, instead of writing X, we're going to put F of X in its place. So what that would look like is this entire function is going to get substituted in where the X is. So instead of 5x plus 4, it's going to be 5, and we're going to put the function F in here. There we go. All right, so we'll go ahead and distribute. Wow, this one's a lot easier than the last one, huh? Give me this on a test. Okay, 5 plus 4 is 9. There it is. So the function on the right gets substituted into the function on the left. Okay, we've got some new functions now. So check yourself, make sure you know who's going to get substituted into who. Hopefully you said G is going to get substituted into F. So you'll take F of X, but instead of having an X in the parentheses, we're going to put G of X in for the X. All right, so we're going to take G of X and we're going to substitute it in for the X. So this is going to be 5 parentheses, the square root of 5x plus 5 squared minus 1. All right. Okay, so the squared and the square root will cancel each other out. So we end up with that. Then we'll distribute the 5 in. There we go. Okay. All right, let's try it the other way around. So instead of F compose G, G compose F. So F is going to get substituted into G. So F is inside of G. So we're going to take this 5x squared minus 1, and we're going to substitute it in right there. This one's a little tricky. There's going to be a little curveball. Hopefully you've got this part. The curveball doesn't really have much to do with composition. All right, so 5 times 5, we got 25x squared. And 5 times negative 1 is negative 5. Oh, I made a big old radical when I didn't need to, because these guys are just going to cancel. All right, so now this is going to be 5. So let's split it up. This is going to be the square root of 25 times the square root of x squared. So this is going to be 5. And it turns out that these do not just cancel in the way that the other ones did. This actually becomes the absolute value of x. Let's talk about that. Let's also convince you. We'll graph it. So what I'm claiming is this way, it becomes not just x, but we need some absolute value brackets on it. But this way, they do just straight up cancel with each other, and I don't need absolute value brackets on it, okay? Let's talk about that. I think the best way to show you is to put a number inside. So I'm going to ask this question, does the square root of x squared just equal x is what we're trying to investigate. Do they just straight up cancel each other? Okay. Well, a good example would be, let's substitute in negative 3. All right, so according to this red part, right? This red part's saying, oh, you could just cancel these guys and it'll just be x. Well, if we just canceled those guys, the answer that we would get would be -3, right? Well, this is wrong. Let's do it the long way. So if we were going to do it the long way, -3 squared needs to be done first because it's under the radical the squaring is. So we had to do this. Well, -3 times -3 is +9, and the square root of 9 is +3. Okay? So it turns out that we would get the wrong answer. So the question is, how can we fix it? Well, just slap some absolute value brackets on that number, and that will turn it into a +3. So that's why we're saying that anytime that you see the square root of squaring, that it's actually going to be the absolute value of the number inside, and now it's fixed. Okay. What's really trippy is if you go to graph these, right? We know what the absolute value graph looks like. It looks like a V. Okay. If you didn't know, I'll just tell you the absolute value is a V. Let's go in and check it out. Let's see what I mean by that. All right. So absolute value of X. There it is. Okay. All right. But now what I'm going to do is I'm going to graph the square root of X to the second. It should be the same, right? And there you have it. It does give us the exact same thing, right? I'll turn one on, turn it off, same thing. Turn this one on, turn that one off. They are identical, you guys. So we've got to remember this one direction, you know, if you're square rooting a squared, that you've got to put absolute value brackets around that number. And so here they are appearing in our function composition. Okay. All right. That was tricky. You know, don't stress too much on that. It doesn't come up super often. Hopefully this over here, you know, makes sense to you so you'll remember. And as you're going through, go, dang, one of them's an absolute value X. And then just plug a negative number in and you'll figure out, you know, which one's going to be what. Okay. So now we have numbers. Now you could do it the same way that we just did it. That's fine. But I find that when there's numbers there, that there's an easier way. Okay. So when there's numbers there, we still work from right to left. So I would substitute 9 into G, and then whatever I get from that gets substituted into F. Okay, so let's see what that looks like. So the very first thing I'm going to do is I'm going to substitute 9 into G. Okay, so G of 9. Well, that just means put a 9 right here where the X is, right? So we've got 2 times 9, take away 8. 18, take away 8. That gets us 10. All right, now we said the answer that we get from that, we substitute into F. So we're going to be putting the 10 in here now. So we've got 3 over 10 minus 4, 3 over 6, which if you divide both of those numbers by 3, then you're just going to get 1/2. So the final answer is going to be 1/2. There are other ways to do it. I'm just trying to give you what I consider to be the simplest, okay? All right, so we're going to substitute 6 into F, and whatever we get from that, we'll substitute into G. All right, so let's go ahead and substitute 6 into F. Okay, so I'm getting 3/2, you guys. Now we're going to take that 3/2 and we're going to substitute it in to G. So we're going to put it right there. So 2 times 3 over 2 minus 8. So these 2's can cancel with each other. So we're just left with 3 minus 8. And that gets us -5 for the final answer. Okay, not too bad. It's way easier when there's numbers, huh? All right, so just work from right to left and you'll be good. Okay, so finding the domain of composite functions, okay? Basically, you're going to find the domain of the innermost, the function on the right. Then you're going to find the domain of the composition of the two functions. And the final answer will be the intersection of both of those. Okay. So let's take a look at what that means. It's funny because let's say we have something like G compose F of X. G's domain does not matter at all. Don't care about G's domain. Because according to what this says up here, we care about the innermost and the composition. So the innermost would be F, right? What we mean by innermost is, oh, sorry guys, is G with F inside. So the innermost would be F in this case. So we don't care about G at all. Okay. So basically the one on the right we care about and the composition we care about. Let's see this in action so we can make sense of it. Okay. All right. So let's come in here and see, why we only care about the innermost function. Okay. So in this case, the innermost function would be G since it's the one on the right. Okay. So let's try to see why the domain of G matters. Okay. All right. And only G specifically. Okay. So if we were to do G or F compose G, then G is going to get substituted into F. So we are going to take 5 over X and we're going to substitute it in where the X is. Okay. So F compose G of X, or F of G of X, right? F of G of X would look like this. 1 over, and instead of writing X, we're going to put 5 over X, take away 2. Okay. Now, let's go in and find the domains. This is just taking a detour really quickly. We're going to find the domain of F. We're going to find the domain of G. And eventually we'll find the domain of F compose G, right? All right. Doesn't want me to type. There we go. Domain of F. Domain of G. Domain of F compose, or F of G of X. Okay. All right. All right, so if we're looking at F, we know that the bottom of fractions cannot equal 0. So we know that X minus 2 cannot equal 0. So if we add the 2 over to the other side, we get that X cannot be 2. And that's kind of obvious. If we substitute a 2 in, 2 minus 2 would get us a 0 in the denominator. And we know that 1 divided by 0 is undefined. Okay. So we're saying everything except 2, right? Here's 2. We're going to open circle it. Everything this way is okay. Everything this way is okay. So that would be from negative infinity to 2, union from 2 to infinity. Now what we're saying is this doesn't matter. This actually isn't going to come into play, okay, in the final product. So this one doesn't matter. Okay. All right, let's go and get the domain of G. So we can see that X cannot be 0. X cannot be 0, or else we would have a 0 in the denominator. Okay. So for this one, we'll open circle 0, but we'll say everything this way is good and everything this way is good. So from negative infinity to 0, parentheses, 0 to infinity. Remember, we're putting parentheses because we don't want to include it. Okay, and we'll get the domain of F compose G, and then we'll take the intersection in a second. Okay, but below this, I'm going to put does matter. Now, why does this matter, right? Well, look over here. Is it okay to substitute in 2? Yeah, if we put a 2 in, we would just get this. At 5 halves, 5 halves, take away 2. Yeah, that's 2.5, take away 2. Yeah, we'd get this. Okay, and that would just get you 2. So it's okay to plug in or substitute in a 2. Turns out that the domain of F does not matter. But Oops, let me redo that, you guys. But we still can't substitute in 0. If we were to put in a 0 into this, right here, we would have something that's undefined. So we wouldn't be able to continue and get an actual value out of that, okay? So the value, the domain restrictions for G, for the innermost function, let's say, do matter. All right, now what I'm gonna do is I'm gonna proceed to finish finding F compose G. We're gonna clean that guy up. I think the easiest way would be to multiply everybody by an X. And I'm doing that to get rid of the fraction within the fraction, okay? So what this gives us on the top, X times 1 is just X, and it allows us to cross cancel those X's right there, leaving us with just 5. Okay, so this is the answer for F compose G of X. Okay, now, what would be the domain restrictions for that? Well, we know that the denominator cannot equal 0. So we know that 5 minus 2x cannot be 0. So if we move the 2x over, 5 cannot be positive 2x. And then if we divide by 2 to both sides, we get that x cannot be 5/2 because these will cancel. So x cannot be 5 over 2. So on a number line, you got 5 over 2 or 2.5. We'll remove that, but everything this way is fine and everything that way is fine. Okay. All right. Now, by the way, the interval notation would be this, right? We're just practicing this, making sure that we get good at it. I don't know if in the long run we need it, but it's always good to practice it. Okay. So remember that to find the domain, it's going to be the intersection of these two. Okay. So we need the intersection of G and F compose G. Try to get this of G and F compose G. Okay. All right. So if we look at the two, we've removed 0 and we've also removed 5/2. So we've excluded 0 and 5/2. So on a number line, 0's out, 5/2 is out. So we're going to open circle those, but everything in between and, to the right and to the left are okay. All right. So if we were to write the interval notation for this, right, this would be from negative infinity all the way up to 0, from 0 all the way to 2. Oh, 2, 5/2, guys, sorry. From 0 to 5/2, and then from 5/2 all the way to infinity. And so that's going to be the answer for the domain of the composition here. So it won't be super evident that 0, like, oh, what is it? That 0 is a restriction. You can see it here that it's a restriction, but I don't know if in the final answer, you wouldn't be able to see it, okay? So you do have to remember, okay, the innermost function G, I've got to find its domain, okay? All right, let's go ahead and try another. All right, so it's F compose G again. Okay, so let's find F compose G. So F compose G means that we've got F with G inside of it. So we are going to take this and we're going to substitute it in right there. So this is going to be 3 over 3x minus 2 plus 2. And the minus 2 plus 2, those will cancel with each other. So we get 3 over 3x. And so these will cancel with each other. And just make sure you remember that x is in the denominator. So there's a 1 in the top, because 3 divided by 3 will get you 1. And then the x will be in the bottom. So that is the composition. Okay, now I'm not going to do everything I did last time. I did everything last time to kind of show you the y's. but we're going to move through it a little bit more quickly. All we need is G. We need the one furthest on the right. Okay, so we're going to get G's domain. Domain of G. I should put that like this. Okay. So the domain of G, well, G's linear. It doesn't have a radical. It doesn't have a fraction. That means that its domain will be negative infinity to infinity. There are no restrictions. Okay. But then we have to look at the domain of F composed G now. All right, well, that does have restrictions. We know that X cannot be 0. Okay, so if we put the two together, this one has no restrictions. This one has 0 as a restriction. Then 0 will be a restriction, right? Okay, so we know that we can't have 0. But everything this way is good. Everything this way is good. So it's going to be from negative infinity to 0 and 0 to infinity for the answer for the domain of F composed G. Okay. All right. So pretty easy once you understand, right, that the innermost function has to be defined or else we'd have nothing to substitute into F because we know it goes from right to left, right? So any values that will make G undefined, that means we'd be plugging undefined into F, which you can't do. So you've got to check this one on the right to make sure that it's going to be at least defined. And then you've got to check the final product and take the intersection of the two or the final composition. All right, now these next couple examples were more designed to get you ready for calculus. In calculus, something that students tend to struggle with in calculus 1 is the chain rule. And the chain rule, it's tough because a lot of students can't recognize that function composition is happening. Okay, even it helps you with u-substitutions when you're doing antiderivatives. So this next two examples, example 6 and example 7, are really geared towards that. So it says, given h of x, find two functions f and g such that h is f composed g. Now, it turns out there's infinitely many correct answers to this. The first one I'll show you will be the one that will hope you recognize in calculus. But then we'll show you, hey, it turns out there could be a lot of different f's and g's. So there's actually infinitely many answers here. Okay. All right. So first of all, I'm noticing that the inner function, the thing that is inside, looks like 3x minus 7. And the inner function would be g with the way that this is written. Okay. So I would let g of x be 3x minus 7. And then you just want to pretend that whatever you made g of x is just a big X, and that'll help you find the other function. So it's going to be square root of x. Yeah, just imagine you took all of that 3x minus 7 and said, just let it be x. Okay. All right. So this works. Let's check it. So this is what I would say is the best answer. I kind of going to say, yes, there is a best in this case. This is the one we want you to see. Okay, so let's check it. So h of x is supposed to be defined according to the directions as f compose or f of g of x, right? Whatever. All right, so it's going to be f with g inside. So let's do that. So if we were to take g and we were going to substitute it into f, that means that we would put 3x minus 7 into this spot. And if we did that, what do you know? You would end up getting exactly what we hoped you would get. Okay, so this was us checking it. All right, now let's come up with another example, just so you get used to your eyes seeing this. So another possible example could be, well, why don't I let g be 3x? And remember we said that whatever you let g be, just imagine putting a big X there. If you did that, then this would be the square root of x minus 7. This would be another possibility for two functions such that when we compose them, we get h. Let's check. So remember, for h of x, we're going to be taking f and substituting g into it. So if we were to substitute 3x in for the x, then you can probably see it already that we would end up with the square root of 3x minus 7. Okay. And then there's always the trivial, composition, which is silly. I don't even like to bring it up. It's so silly. But you could always just let, I don't even want to bring it up because it's so silly. But let me show you how there could be even more, because you might be like, well, how are there more than that, right? All right, so let's see here. Well, I might have to think here about this. All right. Let me do, well, I didn't think about this ahead of time, you guys, and I'm not good at these on call. Let's see, what if we put, I don't know, let me just put 3x minus 1 in. Okay. And then let me think about what I'd have to put for x. If I put a 3x minus 1, and then I were to substitute that into about the square root of x plus 8. Okay, let's see if this works, you guys. This is just me trying to come up with something pretty quickly. Let's see, check. Okay, so we know that for h, it is f with g inside of it. So we would have to take this and put it in where the x is. So if we did that, it would be the square root of 3x minus 1 plus 8. And that would, oh, I have my signs wrong, you guys. Let me do some fixing here. I think this guy needs to be a plus and this guy needs to be a minus. Just kidding. Take two. Let's try this again. So if we substitute 3x plus 1 in where the x is, then we have 3x plus 1 minus 8, which would get you 3x minus 7 like we wanted, okay? So infinitely many, if I could say which one is the best, it's going to be this first one, because this is the one that's going to get you ready for u-substitutions and for the chain rule when you get into calculus. Let's try it again. Now, I'll probably only do like maybe 2 on this one, and I'll definitely do the best, okay? All right, so the one that we're hoping that you would see, again, it's f with g inside of it. So we're going to let g of x be the innermost. So I'm looking at this x plus 1, and I'm thinking that should be g. And then for f, if we just let that x plus 1 just become a big X, then it would be x cubed plus 8. Let's see if this guy works. Okay. So if we're going to do h of x, which is f compose g, or f of g of x, then we would have to take g and substitute it into f. So we'd have to take g and substitute it into f. That's going to get us x plus 1 cubed plus 8. And that indeed matches the original. Okay. All right. Wondering if I even just want to stop there. Yeah, I think I'll stop there, you guys, because that's the one I'm hoping you'll see. Okay. Example 8. So this example is geared towards showing you an instance where if we have 2 functions, why we might want to compose them. So hopefully that comes across, okay? All right, so it says a party balloon is being filled with helium. As the balloon is filling, the radius of the balloon is changing at the rate of 3 inches per second. So we're going to make some assumptions here. Let's assume that the balloon is a sphere. It doesn't straight up say that. I think it should say spherical balloon, so we know. That is a big assumption. Most balloons are not, spherical. So this is just going to be an estimate, but good enough. Okay. Assume the balloon is spherical. I cannot. Is that how you spell it? Okay, looks so weird right now. Let me just say is a sphere. That's better. Oops. There we go. All right, remember a sphere, you guys, is just a 3-dimensional circle, right? It's a ball. So this is what we're assuming. We're assuming it looks like this, okay? We'll just tie the little loop at the bottom. Okay. All right, so let's try to find a function for the radius. So where my mind goes is it starts like kind of automatically t-charting it. Like, okay, when time is 0, we haven't blown the balloon up, so we know that the radius is 0. When time is 1, it's changing 3 inches per second. So now it really will have a radius. Its radius should be 3. Okay. Okay, a little while later, another 3 inches on the radius. So now it should be 6 long because it's doing 3 every second. So 3 plus 3 means it'll be 6. And then if we go another second, add 3 to that, it should be 9 now. So when t is 3, we should get 9. And maybe this is enough for you to start to see what the function needs to be. If I were to put this into a t chart, we're saying when it's 0, it's 0. When it's 1, it's 3. When it's 2, it's 6. And when it's 3, it's 9. And maybe you can just see that's what's happening every time is we're multiplying by 3, multiplying by 3, multiplying by 3, multiplying by 3. So that's the reason why the function r of t, the radius in terms of t, will just be 3 times t. Okay, you can go in here, you can check it, make sure it works. We know that when we plug a 2 in, we should get 6. So let's substitute a 2 in, and what do you know? We get 6. We know when we substitute a 3 in, we should get 9. Boom, it's working. Okay. All right, so there's our function for our radius, to find our radius as a function of time. Somebody could substitute at any second, and they could find out the radius. Write a function that expresses the volume of the balloon as a function of its radius. So this is really just asking you, do you know the volume of a sphere? And so probably most people would be like, no, I do not. So just Google it. Type in what's the volume of a sphere. Okay, so I don't know what's up with this. There we go. We need the volume of a sphere. If you don't know it, Google it. Okay, so the volume of a sphere, if you were to Google it, would just be, and I'm going to put v of r, it would just put v, but it wants us to write it as a function of the radius. So I'm going to use function notation, but it's going to be 4/3 pi r cubed. All right, so that's just something you would straight up Google. You don't have to work for that guy. All right, let's go to C. Evaluate v compose r and interpret the meaning. All right, so remember that v is 4/3 pi r cubed, that r is 3t. So we're going to be substituting r into v. So we're going to take 3t and we're going to put it right there, you guys. And that's going to get us v of r of t, or v compose r of t. All right, so we got 4/3 pi 3t cubed. So we've got 4/3 pi. We're going to cube the 3. And we're going to cube the t. Both of them have to get cubed. So 3 times 3 times 3 is actually going to be 27. And then t cubed is just t cubed. I'll just put them together. Okay. All right, so we can cross cancel, might as well. 3 goes into 27 9 times. So if we just multiply straight across, the 4 times the 9 is going to get you 36. And there's a pi and there's a t cubed. So this is going to be v of r of t, or v compose r of t. Or v compose r of t, yeah. Okay. Now it says to not just like find it, but like interpret its meaning. So the difference between this function here, the one we found, and this other v up here is, this is the volume in terms of the radius. The new one we found is the volume in terms of time. So this gives us the volume in terms of time. Now we'll talk on this next example why that's important. Why would we even care? Okay. It's going to shortcut things for us. It's going to expedite it. Somebody said something like, hey, at time 2, what's the volume? Well, we'd have to substitute 2 in here. Multiply by 3, we get 6. And then we'd have to take the 6 and substitute it in here and do the math. And then we'd finally be able to get the volume. Well, over here, it's a one-step process. If we want to say, well, what's the volume of the sphere of the balloon at time 2? Plug 2 into this, done. I don't have to use two functions. It's done in one. And this next example is going to actually prompt us to do that math so we can see why it's more efficient. Okay. All right. So let's find it without assuming, we'll say this will be the way without v compose r of t. Okay. So, this is without v of r of t. And then over on the other side, we'll show with v. And I can't get it. There we go. Picky today, huh? With v of r of t. Okay. And then you'll see, oh man, yeah, it's way better to just plug the two functions into each other, and then we could just use the one. Okay. All right. So without it, we've got these two functions. Okay, I'm trying to find the volume. But the first thing I'm noticing is I don't have the radius. I have the time. I have the t. Remember, this is t right here, right? Because it's v compose r of t. So we don't have the radius is going to be my first comment. We can't find the volume since we don't have the radius. Every now and then I lose my mouse. Okay. Okay, so let's find the radius. Okay, so we have this other function, right? Which is that r as a function of time is 3t. So we're going to substitute in time 2 to get that the radius is going to be 6. Okay, so now that we have the radius, I know we already found that, you guys, but we're just pretending right now we didn't. Now we can finally go here. All right, so it's going to be v of 2 equals 4/3 pi 6 cubed, which equals 4/3 pi 216. Now 3 goes into 216, 72 times. So we just have to do 4 times 72, you guys. I know it's going to be an 8 and then a 28. So it looks like it's going to be, and this is going to be cubic inches because it's 3-dimensional space when we're finding volume, right? So 288 pi inches cubed, okay? All right, now, if we use the v compose r of t that we found, which was, let me go back and check, forgot already, 36 pi t cubed. Okay, well, t is 2, right? So we're going to substitute 2 in right here. So v compose r of 2 is 36 pi 2 cubed. It's 36 pi times 8. And if we do 8 times 36, let me get this guy out of the way. 8 times 36, then we get 288. Look how much quicker that was, because it didn't require us to use two functions. It required us to just use one. And hopefully you're seeing when we substitute this one into the other one, it replaces the need for us to have to plug the 2 into this one, get a number, and then plug the number into the other one. We can just straight up plug it in now that we plug the two functions into each other. All right, so it says to interpret the meaning. So what is the 288 pi? Well, that would be the volume of the balloon. This is the volume of the balloon at 2 seconds. And of course, you'd probably want to like actually substitute this into the calculator, you guys, because you'd want an actual value. So we have to multiply this by pi. Shift pi equals, and then boom. So it'd be 904 approximately. I'm going to round. 0.79 or let's do 0.779. 0.779 cubic inches. Okay, that's the approximately. All right. Okay, so that finishes off 2-3, you guys. Big deal if you're somebody who plans on continuing on, even beyond calculus, even if you want to be like a math major. Boy, we use this function composition a lot in like abstract algebra and other courses. All right, guys, take care.